Bismillahirrahmanirrahim. My name is Muhammad Said Liaquat and my ID is 002. My program is BS Biochemistry. Today my presentation topic is Atomic Absorption Spectroscopy. My group member are Saad Sayed, Saud, Wasif, Usama, Etisham and Mozam Arslan. Content: Introduction, History, Principle, Composition or Instruments, and Working Advantages and Disadvantages, Application. First of all, Introduction. Atomic absorption spectroscopy or AAS is an analytic technique commonly used for qualitative and quantitative determination of element in samples such as aqueous solutions, waters, metal, metalloid, glass, drug, food, environmental sample, and waste and biological samples. The technique is based on measuring the amount of electromagnetic energy of a particle wavelength which is absorbed as it passes through cloud of atom of a particle element, chemical element coming from sample and standards. So it is very simple technique for detecting the metal. So it also measures the concentration of metal in the sample. It can analyze over 62 elements. It is very simple. So next is the history. The first atomic absorption spectroscopy was built by CSIRO scientist Alan Walsh in 1954, shown in the pic Alan Walsh with spectrometer. So next one is principle. Electromagnetic radiation is a form of energy described by classical physics as a wave made of mutually perpendicular fluctuating electric and magnetic field that propagate at a constant speed. It characterized by a wavelength lambda and frequency v, f, and speed of light is c. So the technique is basically a principle that generated in an atomizer can absorb radiation at specific frequency. Atomic absorption spectroscopy qualifies the absorption of a ground state atom in the gaseous state. Atom absorb ultraviolet, visible light and make transition to high electro energy level. So concentration measurement are usually determined from working curve after calibrating the instrument with standard of known concentration. Concentration on x-axis and absorption on y-axis. It is not idealized. It curve at the end. So these are instruments are a component of atomic absorption spectrum. So first of all, light source. I will explain 8 component of AAS light source. Hollow cathode, hollow cathode lamp, and first of all, I will explain the history of light source around 1954 when development of technique was starting. Source of continuous emission were used. This means that it was used light in the visible and adjacent UV light. First range shown the necessity of a spectrometer with 0.002 nanometer and using this source which was impossible with equivalent equipment available by that time. So it is it contains tungsten anode and a hollow cylindrical cathode made of element to be determined. These are sealed in a glass tube filled with an inert gas. Each element has its own unique lamp which must be shown for that analysis. So next is the hollow cathode lamp, and hollow cathode lamp filled with inert gas argon or neon, where an anode and a cathode are placed. The cathode contains an element whose spectrum is required basically in a pure source of appreciated alloy. For element that emit radiation in the ultraviolet region, front window of emission is made of quartz. Made the glass of tube absorb UV radiation. So next is EDL. EDL is electrodeless discharge lamp is another atomic light source lens source used in AAS. The EDL is also available in a multi-element format. The EDL is fabricated by sealing a small amount of metal or metal iodide of interest in a quartz tube filled with an inert gas, usually argon to reduce pressure. So next one is nebulizer suck up liquid sample at controlled rate, create a fine aerosol spray for introduction into flame. Mix the aerosol and fuel and oxidant thoroughly for introduction into flame. So most important is atomizer. There are two type atomizer I will explain in the next slides. So first is atomizer. Element to be analyzed need to be in atomic state. So it is devised to produce a fine spray from a liquid. Most combustion imply an atomizer in which fuel is forced under high pressure through a oil force. The function of any atomizer is to produce as homogeneous a spray as possible. So this done by exposing the analyte to high temperature into flame or graphite furnace. So first of all, I will explain first type of atomizer, flame atomizer. To create flame, we need to mix an oxidant gas and a fuel gas. In most of cases, air acetylene flame is used. Liquid or dissolved sample are typically used with the flame atomizer. So first, in inert gas enter into the flame atomizer, and then it move on the burner and to flame hood. So next is the graphite atomizer. It uses a graphite coated furnace to vapor the sample. In graphite sample are deposited in a small graphite coated tube which can then be heated to vaporize and atomize the analyte. The graphite tube was heated using a high current power supply. So next one is monochromator. Monochromator is a vital optical component of the atomic absorption spectrometer. It plays the function of isolating the wavelength of interest from the broad spectrum of wavelength emanating from the hollow cathode lamp. For a brief description of monochromator component, what are their role pros through the article discussion and the resolution of light in atomic absorption spectroscopy. The ideal distribution of monochromator output is triangle shape. So the selection of of the specific light allows the determination of the selected element in the presence of other. So next one is uh, detector. The detector is placed in front of exit slit and receive the determined photon by monochromator. So it transforms lightning energy in an electrical signal that is amplified and measured. Detectors mostly used in old equipment and photo multi-values. With modern equipment, they are being substituted by a system based on solid state detector type (CCD). There are similar digital cameras. So modern CCDs have 1 to 50 million pixels working each one of them as individual detector. So next one is calibration curve. It is the last part of component of AAS. The calibration curve is used to determine unknown concentration of an element. For example, that the instrument is calibrated uses several solution of known concentration. A calibration curve is produced by which is continuously recycled as more concentrated solution are used. The more concentration solution absorb more radiation up to a certain absorption. The calibration curve shows the concentration against the amount of radiation absorbed. So next, I will explain working of the component of AAS, in which light source, optical system, and detector, atomization of sample, flame aspiration, electrothermal atomization, and background absorption. The common source of light source is a hollow cathode lamp. This contains a tungsten anode and a cylindrical hollow cathode made of element to be determined filled with inert gas. Pressure of between 1 nm to 2 m and 5 nm. Gases and bombard the cathode and eject element from the cathode in a process called sputtering. So light source here is shown a glass shield and anode, and here is cathode and inert gas, neon or argon. Here is, and this one is hollow cathode lamp. So next one is the optical system and detector. A monochromator is used. A monochromator is used to detect to select the specific wavelength of light. So next one is spectral line absorb the sample, produce an electrical signal that is signal proportional to light's intensity, and a double beam of spectrometer. Modern spectrometer incorporate a beam splitter so that one part of the beam processes through the sample. So next one is atomization. System are commonly used to produce atom from the sample. Sucking a solution of sample into flame electrothermal atomization is where a drop of sample is placed into a graphite tube that is then heated electrically. So in this diagram show the atomization, and these are particle. So next one is working of flame aspiration. Typically burner and spray chamber and flexibility capillary tube connect the solution to nebulizer, and working of a background absorption is source. There are two sources of background radiation. Background absorption are hollow cathode lamp and uh, deuterium lamp. The deuterium lamp produce broad band radiation, not specific spectral line as with a hollow cathode lamp. By alternating the measurement of the two light source, generally 50 to 100 hertz, the total absorption is measured with the specific light from the hollow cathode lamp with the background. So next one is advantages and disadvantages of AS. The main advantages of graphite is the slurries and solid sample can be analyzed in addition to sample in a solution. It shown greater sensitivity that AS smaller quantity of sample are required, 5 to 60 microliter. The atomization process is more efficient comparing to AAS. And the disadvantages of AS, it is expensive and low sample throughput, so it required experience operator. Next one is application. Application in which agriculture, forensic, clinical analysis, environmental analysis, pharmaceutical, and industry and mining. First of all, I will explain agriculture. Atomic absorption spectroscopy is frequently used in agriculture and study of environmental sciences. Atomic absorption spectroscopy, as well as atomic influences spectroscopy, which analyze the light emitted from a sample rather than the light absorbed, are frequently used in various fields of agriculture study. Typically, they are used to identify and analyze the presence of potentially harmful element in the environment. So next one is forensic. Forensic atomic absorption spectroscopy has been utilized in industry of forensic of many years. Using this technology, forensic scientists can perform in-depth analysis of blood sample, brain, muscle, gunshot, power residue. So this technology has vastly improved the accuracy of a toxicology report in cases of metal poisoning. So next one is clinical analysis. Analysis metal in biological fluids such as blood and urine, the main important application. So next is atomic absorption spectroscopy are too closely related instrumental technique that have many application in different field. Clinical chemistry, these techniques will establish for quantitative measurement of essential and non-essential element found in the blood and tissues. So next one is environmental analysis, monitoring our environment, for example, river, seawater, drinking water, petrol, and wine, beer, fruit drinks. So next one is pharmaceutical. In some pharmaceutical manufacturer processes, minute quantities of catalyst used in process are sometimes present in the final product. By using AS, the amount of catalyst present can be determined. So next one is mining. By using AS, the amount of metal such as gold in rock can be determined to see whether it is worth mining the rock or extract the gold. So last one is industry. Many raw material are examined and AS is widely used to check that the major elements are present and toxic impurities are lower than the specified. For example, in concentrate, where calcium is a major constituent, the lead level should be low because it is toxic. So that's all from my side. Thank you so much. If you have question, you can ask in the comment section. Thank you for watching.